Material science with simple introduction, properties, and real life diagrams. We are going to deal on ferrous and non-ferrous metals, ceramics, polymers, and compositions. Okay, let's take definition of material science. Material science, it is an interdisciplinary field involving the properties of matter and its applications to various areas of science and engineering. Okay, now the second definition also involves the study of structures, properties, and behavior of all materials, the process to manufacture new products from them, and research into recycling and environmental friendly disposal. Okay, now if you look at the picture down here, you will see various waste buckets. Now, the glass bucket, which is the green one, is used to put any glass, all glasses used to be there. We have the plastic, which is the brown one. Any plastic, all the plastics can be there. Then we have the metals, we separate metals there, and we have the papers, which is blue one, and the organic, which is the orange one. Now, after all these have been separated, it means that they can also be recycled. Like the rubber, which is the plastic, can be recycled if it's rubber cup. Once it's been taken to the factory to be recycled into a rubber bottle or any rubber material. We have the metals. The metals can be remelted, then form then used to form another product. Glass, same as the paper, same too. Also the organic can be taken um, to the farm for manure. Okay, let's check. Okay, engineering materials, we're going to deal on all this. Okay, we have the metal. Under the metal we have the ferrous and non-ferrous metal, and under the non-metals we have the ceramic, we have the polymer, and the composition. Now we are going to start from the metal. After the metal we'll come to the non-metal. All right, now let's first of all look at definitions of them. Metal are solid at room temperature and are crystal lattice. Crystal lattice is the main key point on metal. So metal are solid at room temperature and are crystal lattice, in which their atoms are held together by strong metallic bonds. Okay, now let's look at non-metal. Non-metals exist as covalent molecule and held together by weak forces. Covalent molecule is the key word on non-metal. The keyword on non-metal is covalent molecule. The keyword on metal is crystal lattice. Okay, now let's go to the next one. Physical properties. Okay, now it depends on the arrangement of atoms or molecules in crystal lattice. Now we have the simple cubic, we have the body centered cubic, there is extra ball inside the cubic, we have the face center cubic, there are balls on the faces of the cubic, the 6 faces of the cubic, there are balls on them. Let's check the chemical properties. Chemical properties, it depends on the number of valence electrons present in the atomic structure. Now these are how the structure looks like. The electrons which are the outside shells which are on the outside shells are equal in number to the proton, which are the blue ones in the nucleus. Now the first shell is 2 in number, always 2 in number. Then the next shell, which is the second, and others are all 8 in numbers. Now, if how you get a valence electron? A valence electron, like if you are looking for a particular atom, the total number of electrons on the last subshell determine the valence electrons. For instance, if we have like 3 electrons, now if it's one, it is one valence electrons. If it's two, it's two valence electrons. Now notice the valence electrons determine the positive and negative ions of every atoms before being combined to form an octet state. There's a video for that. You can watch them to get more understanding. Now let's look at the classification of metal. We have the ferrous metals and the non-ferrous metals. Now let's talk about the ferrous metals. They contain iron. That is the main key word there. They contain iron and also magnetic in nature. Now let's look at it. Includes types of ions, steels and their alloys. Now for the non-ferrous metals, they don't contain iron and are not magnetic in nature. Those are the key words there. So take note of that. Examples are aluminium, gold, silvers, lead, tin, coppers, etc. Note this. They are malleable and lightweight. That's why they are used as aircraft and also as in boats and ships. Why they are used in making boats is because non-ferrous metals hardly get rust. Now let's look at the ferrous metals. We have the ions. They are used in making chains, the cranes, the iron pressing iron. They are used in making tools and other things made of iron. There are so many of them. Now this is iron ore. Iron ore is formed from the sedimentary rock. Is formed from sedimentary rock. Sedimentary rock are formed from organic composites. Okay. Now these are the steels. The steels are used in making watches, the car body, the beams, the sinks, in the kitchen, and so many. The plates, the spoons are all made with steels. Now these are for the non-ferrous metals. Non-ferrous metals, they are used in making jewelries, like the gold jewelries there, the gold coins, and so many other things made with silvers and golds. There's so many things. Now we have the tin. The tin is part of the non-ferrous. We have the copper. The copper are used for electrical purposes. We have the brass. They use them in drawing, in making so many various images. Alright. Now this is the chart. We are through with the metals, which are under. So the ferrous and non-ferrous, and we are on the non-ferrous metal and non-metals. And under the non-metals, we are going to look at the ceramic, polymer, and the composition. The ceramic, the polymers, and the compositions. Now the ceramic, they are inorganic and non-metallic materials formed in a very high temperature. These are how the ceramic are being formed. Just like your clay pot. The clay pot. Now, raw materials of ceramic. This is how ceramic is where ceramic is gotten. When it's taken from here, pass through a lot of process, mixing, sieving, and all of that. Then molding and heating, painting, all of that. Now let's look more. Now ceramic are commonly electrical and thermal insulated, like the plug, the transistors, the capacitors, the fuse, the electric supports, etc. We have the plug down there, the capacitors are here, the resistors, the diodes, and these are the electrical supports. They are using These are the electrical support. They are all in different sizes. Some are bigger, some are human size, and all of that. Now we have the fuse, we have various arms, we have the 7 arms, 10, 2 arms, and all of that. Now ceramic are brittle and can break. We have the toilet bowl, we have the hand basin, we have the plate, we have the cups, etc. Now ceramic are sensors and also found in our refrigerators, our teeth, and bones. Now take note of this, they are formed by 2 or more elements. The ceramic found in our teeth, have you ever noticed this? As in, some parts of the teeth remove, and when being chewed, it's sandy. Yeah, those are ceramic found in our teeth. Now let's talk about the polymer. It is produced by a combination of 2 or more organic molecules into a large molecules obtained from petroleum or other agricultural products, and the process of obtaining this is called polymerization. This is silicon circle, is a polymer. Now types of polymers, we have the thermosetting and we have the thermoplastic polymers. Now for the thermosetting, it can be recycled and oh sorry, that's it for the thermoplastic. Now the thermosetting cannot be recycled, cannot be remolded or reshaped, and more resistance to high temperature. Now for the thermoplastic, is highly recyclable and can be reshaped, and chemical resistance. That is, we don't put chemicals like your acid into a metallic vessel. You can only put it a into rubbers. Have you ever asked yourself why is um acid being put into a rubber? It's because it's chemical resistance. That is the number one secret of it. And number 4, it can be melted if heated. Now the particle differences, thermoplastic and thermosetting. Now for the thermoplastic, it looks like an ice being boiled. Once it's being boiled, it changes shape, and it can also be reformed to that particular shape in that cubic form. But using egg as an example of thermoset, once it's being boiled, it can never be reformed. Now examples of thermoplastic, we have the rubber plates, the rubber spoons, the boots, and there are so many. You have the rubber chairs, the rubber table. There are so many things produced by thermoplastic frame. There are so many things. There are so many thermoplastic materials in markets. Now, these are rubber trees. These are how the rubbers are being gotten, then taken to the factory for different processes before getting our various rubbers. Examples of thermosettings: we have the PVCs, which are used in making the insulator materials, the pipes, the containers, the plastic plates, cups, and so on. We have the polystyrene, they are used in making the dispensable plate, cups, and so on. We have the polyamide, they are used in making the ropes, the beds, the wares, and so on. Now these are the PVCs. They're used in making the tapes, the wires, the various pipes, the ceilings, and the polystyrenes are used in making the cups, the plates, the party plates, the CD pack, and so on. Now the polyamide is making the rope. There are various ropes down here. We have the tailoring ropes. Okay. Now they are used in making the bags, the shoes, socks, and make clothes. That is mainwears and polyamide mainwears. Now there is making mainwears. Now these are polyamide main underwears. There is making main underwears. These are polyamide main wears. Now one thing about this polyamide, one thing about the wears is because it is elastic. Once it can fit anybody. That's what I mean. It can fit anybody. Once a lady A put it on, it can also fit lady B and also lady C and lady D. So that is one advantage of polymer wear, the clothes made with polyamide. Now these are underwears for ladies. Like I said, it can fit anyone as long as you have that particular body size made for it. Now talking about the composition, they are formed by combination of two or more materials. Example, we have the concrete, we have the fiberglass, we have the crude oil. Now the concretes are formed by various materials. We know they are formed by sand, cement, mixed with water, and so other materials too, like stones and all of that, for more strength to the material. Now let's look at crude oil. The crude oil are hydrocarbons. They are also examples of compositions. Now we have the fiberglass. The main formation of fiberglass are silicon sand. We have the limestone and soda. These three are the main formations of fiberglass. Now, depending on the kind of fiberglass depending on the uses, then other materials can be added to it. Now let's check them. Now silicon sand. Silicon sand, this is how silicon sand looks like a stone. Is a quartz stone. Those are silicon sands. Now these are limestones. I believe everyone has seen this before. When you go to the building site, you see this. They use it in building. They mix it with the concrete. Alright, now these are limestones. Now this is soda ash. This is soda ash. Now once these three, the limestone, the soda ash, and the limestone, the soda ash, and the silicon sand, they will be mixed in a bucket, stirred together, and then taken to a hot funnel which will be heated for several hours before taken to another vessel for sieving. Then it formed the fiberglass, which are these materials now in part A. Now once it's been sealed, a machine is going to cut it into various sizes. We have the 3mm, we have the 6mm, the 10, and so on. Now these are the fiberglass, things made with fiberglass. We use fiberglass in making the pipelines. The ceilings are all made with fiberglass. Note this, the fiberglass don't get rust. That is why they are used in making pipelines, to avoid rusting. Are all made with fiberglass. We use fiberglass in making the jets, the canoes for sports, the sports canoes here, the banners. We use fiberglass. Now when fiberglass is mixed with polymer, like I said before, depending on the uses, other materials are being mixed to it. Now once a rubber is being mixed to it, that's a polymer being mixed to it, is used to make, we have the panel, we have the ceilings. This ceilings is different from the main polymer ceilings. Now these ceilings are transparent because fiberglass is always transparent. The ceilings are transparent. You can get these ceilings in the bank, in some industrial areas, and also in some houses too. The ceilings are everywhere. Now when fiberglass is mixed with cement, using molding things, amazing things, using molding amazing things. Now when fiberglass is being mixed with white cement, is used in making POP. These are various devices made from POP. So all these are made from fiberglass. Now depending on the uses, other materials added to it. Please don't forget to press the subscribe button and bells button to get the ebook for free. Thanks for watching and hope you enjoyed this video. Thank you.